you can look at your mailbox. Right. When I was a student, my mailbox is space. I don't see any interface with. You maybe 5 minutes, right, to think about it and send your answer in the Zoom chat. Hopefully, Kang Hendra has some uh, bonus point for you to answer the right questions. So I wait for 5 minutes for answering in the Zoom chat.
Recording in progress.
All right, we have a winner here.
Recording stopped.
So, thank you for answering. Yep. The the case ID, timestamp, and activity name. Those can be combination of those
Recording in progress.
that we can map from the email that we received. Right? There are several answers possible actually. There is no mistake here. Right? So hopefully, Mas Taufik can request the the bonus point to Kang Hendra, to Dr. Hendra. I have some gift here from Brunei, but quite difficult to send it to Indonesia. So when you see here this slide, right, I'm showing you a particular mapping where I consider the subject of an email to be the case ID. Right. So like the one that you have it right now in most of the mail system, right? They can group the same subject. When I was a student, it's all individual email, not group by. So it's quite difficult to search an email with the same subject. So we want to group all emails having a particular subject into a single trace in this slide, right? We do this based on the subject field. We use the timestamps to sort the events within a case. And in this case, we see the sender field as an activity name. So although the name is activity, but the sender itself, the guy who sent us an email, can be an activity name, right? Because we have no other options. And the other field and subject to be the activity name. So many mappings are possible, and it depends on the context. And the question is, what is the best thing to do, right, from the mapping that you did? Who can answer? What is the case field? What is the timestamp field? And what is the activity name field? Again, please think about it, and I'll give you another 5 minutes. It's okay. Yeah, we can see this where the student ID is the case ID, the same like Mas Nathanael and Mas Abraham. And then the course is the activity name. The same also with Mas Nathanael and Mas Abraham. And the date of the resource can be also the resource. The other fields correspond to optional information we can use in this process discovery, right? The so again, other alternative mapping are possible actually, besides the one answered by Mas Abraham and Mas Nathanael. It depends on the questions, what you need to take. Right? For example, one can also think of the course as being the case. Cases, activities take time, and we can see the explicit start and complete event. So many event logs have this type transactional informations, and if we have this information, we can have for this process discovery and structure the input format in better way. So the XES standard, XES stands for Extensible Event Stream, is a standard adopted by IEEE. Right? So in IEEE, usually the computer science problems, you can also load these files into these tools, ProM and Scope. And there is nothing that you need to do further. You can immediately start, and there is nothing that you need to do further. You can immediately start the analysis. So you can visit this URL if you want to know more about the standard. The process models. Again, just like with event data, I will give some example of what kind of process models we are talking about. Before we have seen simple process models, right? That describe the sequence of activities. Right? What are the activity sequences that are allowed in the discovery? So not elaborating on all other perspective. This is just in the business process. But next to control flow, you can look at all kind of other elements in the business discovery. For example, you can look at data elements that are driving particular decisions in the business process. So that's why we have and all other perspectives. We deal with the different topics. Right? So right now we want to focus on the control flow and on the discovery of the business models containing control flow business models. But it's important to know that the business process model can also express all of these three perspectives. Right? There are many process model notations. There is a long list here, and some of these notations we can use for different purpose. Is the representations that helps you to find a model that captures reality. Right? This is internal in the process discovery technique. At the same time, you want to visualize the models in particular way, so you need to think about what kind of process model notations does the end. So it's important to realize that the noise notation, you can use fuzzy models. You know, the fuzzy logic actually has fuzzy model. It's quite interesting, right? And here you can see the example of that on the squares A, B, C, D, E, F, G, H represent activity or join. So we allow for all kind of pictures and do not explicitly express it. You don't get the executable model. There is no executable model, but we get a model that is much simpler and maybe much more. How to discover the business process? You can start from the simplest algorithm. We call it as an alpha algorithm. It corresponds to the process discovery is plain. If you see this picture, like in the initial slides, you can focus on the alpha is a symbol from the Greeks. So the alpha algorithm was the first being able to discover concurrency. So it's quite important algorithm. and from the event logs, we want to learn models that can have loops, that can have parallel paths. Also, we don't use the case ID or properties of the case. So we can convert such as event log to a, we can also take a look at a more abstract example. Here we see a log L1 which contains 6 traces, right? 3 ABCD and 2 ABCD, and allows for the behavior that we have seen in the log, even log. And that's like a minimal desire that we have. This is the minimal desire. Here you see another example, an event log which a bit bigger than L1, talking using the more abstract notations. So you can also actually represent the the behavior as a net. You can also represent it as BPMN, business process modeling notation, which is more famous in the business in the industry. That express exactly the same in 2 different languages. Right. So here you see another example of the parallel process models, one in the nets and the other in BPMN, that express exactly the same. And you can, like, you need several forces to keep a plane on the air. Right? We need to work with several forces when we discover a process model. So in this talk, I would like to mostly focus on fitness, which is the ability to replay the observed behavior. But actually, in other occasion, you can learn that it is not simple. We will see that it is not that.
Okay, you go to your job.
Mhm. Okay. What happened with the screen? Are ordering relations. You order the relations. Um, we don't care about the frequencies. What's happened with my screen? Okay. Can you see my screen?
We can see your screen, sir.
No. You can see it?
No, we cannot.
Yeah, I think it's black, right? Black out. What is this? Oh, strange, right? There is a spam from Sam, and then I can. All right. Maybe this is called Zoom bombing. We can have this right now. Where are we? So there was a sequence A B, right? C D that we can see that is followed by A was followed by B, right? No. Oh, I will close on. I will close again. Yes. Screen. Okay. Right. Let me share it again. Where are we? So okay. We have a sequence A, B, C, D, and D, right? Then we can see that A was followed by B. Then log, we can find these relations. Right? For example, if we take a look at the top one, it says that there was at least one case where A was directly followed by B. That's highlighted here. A, we can see that A is sometimes directly followed by B, but B is never followed by A. So we derive this. The last relationship holds if X is never directly followed by Y, and Y is never directly followed by X. We then say that this is a choice relationship. So, for example, if we look at the log and we derive the relationship, we will see that P is never followed. This is the Petrinet pattern that we expect to see is a sequence. If we see that A is sometimes followed by B, but never the other way around, A is sometimes followed by our table. So this is the same logic. So apparently, after doing A, there is a choice between B and C. Note that if we replay this process model, we will get exactly this type of relationships. The corresponding part to XOR split pattern is the XOR join that you can see here. And if you look at the order relationship, I think it's obvious. So B has a causal relationships with D. C has causal relationship with what? D, right? But B and C never followed one another. It's obvious. So if you look at the concurrency, we see this behavior. If we look into and split, where A is followed by both B and C, but they can be done in any order. perhaps at the same time. Then we will find that A is sometimes followed by B, but never the other way around. A is sometimes followed by C, but C is never followed by A, and B is sometimes followed by C, and C is sometimes followed by B. So if you replay the token game on top of these fragments, you will indeed see that this relationship holds. So this is an indication that the process has those patterns. Again, we can look at the corresponding join pattern. So we now see in that again, P and C can follow one another in any order. And we have observed at least once that P was followed by C. And at least once that C was followed by P, typically in different traces. And we sometimes see that P is followed by D, but in the other way around. Sometimes C is followed by D, not the other way around. So based on these patterns, we can automatically construct the model. And so you can see here, we revisit the example and you can see these patterns are there, but actually in this example, it's already a bit more involved. And the alpha algorithm can also handle many more situations. So let's look at this ordering relationship in a bit more detail. When we take an event log, we can talk about so-called footprints. And that is the matrix that you can see here. Every cell in the matrix has one of these four relationships. We have four relationships. Each of them, one of them. So either we have causality in one direction, a causality in other directions. The two activities never followed one another, or they sometimes follow one other in one direction and other times in another direction. So there are only four possibilities that we have. So in this example, A is sometimes followed by C, but C is never followed by A. So if we took a look at the event log, then the corresponding process models, we will see that both actually have exactly the same footprint. So if we look the analysis, if we want to analyze the process model, we look at all the traces and then create the footprint based on all possible traces. This can be a matrix here. So model and event log agree on the footprint, indicating that they have, from a behavioral point of view, things in common. We can take a look at another footprint, another log, L2, and more involved example. And again, we see the same phenomena. The event log and the process model have exactly the same footprint, suggesting that this model is indeed the model of the behavior that we have seen. So to summarize this part, we talk about the footprints. We can see some patterns, certain patterns that are reflected both in the log and in the model. And these are the starting point for the alpha algorithm. The alpha algorithm is very basic algorithm. It contains only 8 lines, but it looks scary for you for the first sight. So I will skip these 8 lines, right? And surprisingly, these 8 lines actually simple algorithm. You can actually discover a wide range of different processes. Right? So processes have concurrency, processes having loops, processes having choice. All of these things can be discovered by a very basic algorithm. But let's see step by step. If we start with an event log, which is a multi-set of traces, and if we construct a business model with alpha algorithm, the first step that we take is we scan the event log to see what are the activities and what are the transitions that we are appearing. So we just look at the symbols that occur in the event log. So this will be the activities in the process model, each corresponding to a transition. That's why we use the symbol T here, transition. Then we have the initial transition T1. These are the transitions that are the first in the trace. So we'll look at all the traces and look at what are the different activities that happen in the first position of the trace. Similarly, we can look at T0, the set of final activities, and activities that happen at the end of the trace. So we have all activities that happen at the beginning and activities that happen at very end. After we have done this, we have the key step to discover places. If you think about process discovery in terms of the Petri nets, the BPMN, it's all about discovering places. We will discover places by identifying set of transitions A and B, where A are the input transition for the place and B are the output transition for the place. And we do that in number of steps. So this is the fourth line of the description of the alpha algorithm. As I said, it looks a bit scary, but if you look at the intuitive idea behind this algorithm, it's very simple. We are trying to find two sets of activities, A and B. And these activities should have the properties. So if we took the two activities in the set A, they should never follow one another. If we took two activities in the set B, they should never follow one another. Even if we take some activity, we should never follow itself. So it's one requirement. The second requirement is that the second requirement is we take any activities in the set A and we take any activity in the set B, there should always be a direct succession between these two activities. So there should be at least one position in the log where the element of A is followed by the element of B. And that should hold for all combination. So that's what we said in this fourth line. So if we take a look at the footprint matrix, we can recognize the structure because we are looking for set A and B where things never follow one another. And we are looking for this other connection where any element of A is directly followed by any element of B, but never the other way around. This is what indicated here in the matrix. So this is what we are looking for, but this is not enough. Line 5 of the algorithm says that we should only look at the sets A and B that are maximum. And it's very easy to see why this is the case. Suppose we have this pair of set of activities A and set of activities B, having all the requirements, then if we remove node in A or B, or we remove the corresponding arcs, then what we see then is that still the properties hold. So in any way, subset of this AB relationship automatically also has the properties that we have. So here you can see two examples, A and B, sets which are smaller and automatically satisfy all the requirements as long as A and B are not empty. They are still there. Right? So that means that we could potentially get many places and we don't want that. So we only retain the maximal elements of this set X. And that's what we do in the step number 5, yielding a set Y which will correspond to the internal places. And so we delete all the elements from X that are not maximal. In that sense, what I've just mentioned, now the remainder of the algorithm is quite simple. PL is the set of places, so all the maximal pairs that we have just discovered in step 5 are places. And we add initial place I and the final place O. It's very easy to understand, right? So it's important to see that that really interesting part happens when we look at the sets A and B. So derive the places that we want to see. Then we look at the arcs, and we already have the translation, we already have the places. Here you see the arcs. So there you can see all the connection from the initial place I to the initial place TI. From all the transition in the set T0. So the transition correspond to the activities that happen at the end. And all internal places are represented by set A and B, and the connection are made accordingly. So this is making the connection, but the real logic were already in step 4 and 5, where we identify the sets A and B. Finally, we go back to the business model where place P, transaction D, and arcs F, and we get the result that we are after. So let's replay these 8 lines. So this is the log, and this is the footprint matrix. So we can see all the relationships from the footprint matrix. Then we execute the different steps of the algorithm, where the key steps are step 4 and 5. So here you seek the relationship X. They contain elements which are not maximal. Some of these elements are contained in other elements. So we remove them, right? 6 of them indicated here. Then we get a set Y. And this corresponds to the internal places. So for example, you can see this, there will be a placing having input A and as output B and E. And this is what we can see in the diagram. Right? So if we feed an event log to the tools like ProM, right, we can load the log, and the log that just we have in the previous slide, and then the ProM will return the model we just saw. Right? So here you can see that alpha algorithm in action on very tiny log. So you can see another example, log L3, and the first question will be to apply the alpha algorithm. What is the footprint of this event log? Try to draw it. If not, then I cannot see. We cannot send it in the Zoom chat, the drawing, right? Okay, I let you to draw in 1 minute, right? But maybe you cannot send it to Zoom. But you can compare your answer with my answer. So let's draw in 1 minute. Right. Have you finished drawing the footprint matrix? And you will see like this, hopefully. Right? This is the footprint matrix that is resulting from it. So, for example, if you look at the row A and column A, you can see that A is never followed by itself. The process cannot be followed by the same process, which is a clear thing that you can see in the log. And then if you look at row A and column B, we see that A is sometimes followed by B, but never the other way around, right? Not like this. So at the log end, you can see that it is indeed the case. You can look at all the rows. For example, we look at C and D. We'll see that C is sometimes followed by D. And sometimes D is followed by C. So suggesting this is the concurrency relationship. So first we build a footprint matrix, and then we apply the alpha algorithm that we have seen before. So given this footprint matrix, we can execute 8 steps, sorry. So you can try this by yourself. What is the model of the result of this one? If you apply a different step, then that is the process model that you can provide. You can discover, you can find. So if you need to check it yourself, that is indeed the result that will be returned. Right? So if we fit this log to the tools program, then you can see exactly the model that we predicted by the alpha algorithm. A little bit different size, but still exactly the same model. Because program implements exactly the 8-line algorithm that we have seen before. So let's take a look at another event, L4. We see that 4 different traces happening at different frequencies. So if we take this event log, we'll discover this process model using the alpha algorithm. And we take all the place. We take a look at the places and the names that they have and identify the 3 sets A and B. You can see that this is actually the model that can be derived based on this log. And also, if you look at this model, you can reproduce all the traces that we see in the log and nothing more. And ProM indeed returns the same model. This is another example. Many examples that you can have. Fill in the algorithm indeed produce the right result. So you can take these event logs. You can see this footprint matrix. L5, you can apply the algorithm. So you see all these 8 steps of the alpha algorithm distinguish the X and Y are the most crucial steps. Then we can get it to the process models. Again, we can see this is indeed the process model is able to reproduce the observed behavior, but also a bit more because the patterns in the log, it suggests that there is a loop. So in summary, the alpha algorithm provides you a basic discovery approach. It has many limitations. I didn't talk about this yet. If we have another chance, we can talk about the limitation of the alpha algorithm. But still, the algorithm is very useful because you can illustrate the key ingredients of process discovery, discovering loops, concurrency, choices, it's all in there. So far, understanding process discovery is very important for you to practice different examples. You can apply alpha algorithm and you can again better understanding of the difficulties that you can see if you want to discover process model just based on the examples. So, yeah, this is the references, especially the first one, discovering the business process using the ARC reinforcement for web service composition. So the business process is modeled as a web service. That's my publication this year. And other publication, you can see that from these related references. Yeah, I think that's all. Yeah, I cannot show you the last slide. So any question will be more than welcome. Thank you for listening and watching and contributing to this lecture.
All right. Thank you, Dr. Arif, for the explanation about business process discovery. It was an interesting explanation. And as I promised before, the Q&A session will now open to all the participants. You can ask the question directly by using the raise hand button or via Zoom chat, and I'll read it for you. For Dr. Arif, do you want to answer the question immediately, or do you want to answer several questions at once?
I can answer it immediately, no problems.
Okay. All right, it's open now for all the participants. Please ask question about the topic. You can just ask directly using the raise hand or via Zoom chat. Oke, Dr. Eva, silakan.
Ya, terima
Maybe you
kasih.
can also ask in bahasa also, no problems.
Oke.
Okay.
Assalamualaikum Dr. Arif.
Waalaikumsalam warahmatullahi wabarakatuh, Bu ya Pak.
Ya, perkenalkan saya Eva, kolega dari Pak Hendra. Sepertinya hari ini memang kita sedang gangguan, Pak. Mohon maaf. Jadi di kampus kami sedang ada pemadaman. Jadi entah kenapa tidak diinfo. Jadi biasanya kalau ada pemadaman dari PLN kami dapat info ngaten nggih. Nah, tapi hari ini tidak ada info. Kemudian genset untuk server di pusat data itu akhirnya tidak bisa mengatasi gitu. Jadi beberapa jaringan memang akhirnya putus. Kemungkinan juga Pak Hendra terkena imbas. Nah, kebetulan saya sedang berada di luar kampus, jadi masih aman gitu untuk jaringannya. Nah, terkait proses bisnis ini, mungkin yang hadir di sini sebagian besar mahasiswa semester 3 memang yang sedang mengambil kuliah fungsi dan proses bisnis. Nah, ini sesuatu yang baru Pak Arif untuk teman-teman mahasiswa terkait proses discovery, menemukan proses dari log event begitu nih. Nah, atau event log ya di sini. Nah, jadi yang selama ini dipelajari mahasiswa ini masih karena di semester 3 gitu. Jadi masih bagaimana memahami proses bisnis di suatu organisasi, kemudian mengidentifikasi proses yang ada di organisasi tersebut dengan cara seperti wawancara, observasi, kemudian analisis dokumen, lalu menggambarkannya ke business process modeling notation itu BPMN. Nah, seperti itu. Lalu kemudian melakukan semacam analisis kualitatif untuk mencari permasalahan dari proses tersebut dan memperbaiki dengan membangun atau mendesain ulang proses bisnisnya. Tapi menemukan dari event log itu memang sesuatu yang masih baru. Jadi ini benar-benar Mungkin untuk untuk mahasiswa masih seperti tadi mengidentifikasi, tapi cukup jelas menurut saya mengidentifikasi event log dari sebuah case begitu ya, case-nya untuk email, kemudian tadi untuk data ujian begitu. Nah, itu memang contoh yang sangat menarik yang mungkin nanti bisa dikembangkan oleh mahasiswa di semester selanjutnya mungkin. Itu Pak Arif. Untuk tools Pak Arif lah, ini saya yang tertarik tadi, tools yang digunakan untuk proses discovery di sini itu mungkin bisa dijelaskan lebih banyak nih. Apa saja, kemudian apakah itu open source atau seperti apa nih Pak Arif? Matur nuwun sebelumnya.
Sami-sami Bu. Ya, makasih Bu Eva. Langsung tadi tentang ini ya, tentang mahasiswa semester 3. Memang ini biasanya sih di semester 5 ya, kita kasih proses discovery materinya. Bukan foundation lagi, tapi sudah advance untuk business process management, sehingga teori dasarnya dianggap sudah paham ya tadi. Cuman yang ingin saya tambahkan itu di business process management itu ternyata juga masih jarang penelitian di bidang itu. Kalau kita lihat ini sebetulnya dari related publication saya ada 8, tapi yang benar-benar sesuai dengan business discovery cuma nomor 1 sama nomor 8. Yang lainnya enggak proses discovery benar. Dan manfaatnya mungkin besar juga untuk proses discovery ini buat mahasiswa yang ada sisi saintifiknya ketika melakukan beberapa kegiatan akademis, kemudian di situ diolah dengan algoritma, itu hasilnya tingkat kompleksitasnya juga lebih tinggi ya Bu ya. Cuman terkait dengan tadi tools, emang kebetulan toolsnya lumayan banyak. Jadi yang saya gunakan baru 1, yaitu ProM, open source dari TU Delft University, dikembangkan oleh TU Delft University, makanya dia open source. Tapi karena open source suka banyak bug-nya, kalau saya pakai itu dia suka error, kemudian feature-featurenya banyak, tapi nggak semuanya bisa dipakai ternyata, karena dia lebih ke arah eksperimental dari penelitian-penelitian yang ada di TU Delft. Kalau mau yang lebih stabil, itu ada tools namanya Disco. Saya ada nggak ya di sini? Disco. Salah satu tutorial saya pakai Disco juga. Ada free version yang dipakai, cuman ada batasan fungsi yang nggak bisa dipakai semuanya karena dia free version. Dia kalau free versinya seperti itu, komersialnya harus bayar. Saya lupa berapa. Cuman pemakaiannya sama kayak ProM. Kita masukkan event log, kemudian kita bisa jalankan berbagai macam algoritma untuk proses discovery, sama yang lain juga, nggak hanya proses discovery. Untuk yang log yang real world, itu kita nggak mampu pakai manual, maka tools ini ya suatu keharusan. Dia bisa memvisualisasikan proses yang berhasil kita discovery dari event log di semua sistem. Apa aja itu masukin datanya, asal dari timestamp dia keluar, ada urut-urutannya, dia akan keluar gambarnya. Jadi menarik. Kadang kita nggak sadar bahwa itu ternyata prosesnya seperti itu. Saya sempat jadikan ini topik penelitian di mahasiswa S2 dan dia menggunakan ini untuk melihat aktivitas dari mahasiswa di e-learning karena selama pandemik 2 tahun itu kita pakai e-learning. Di situ ternyata aktivitasnya bisa digunakan untuk memprediksi seberapa aktif mahasiswa dan nilai yang dihasilkan. Dari situ, dari gambar proses discovery ini kemudian ketahuan ketika mahasiswa itu banyak aktivitas yang menjelang deadline gitu, dengan mahasiswa yang dia terdistribusi ini urutan aktivitasnya, hasil nilainya berbeda. Itu belum saya publikasikan tapi hasilnya Bu. Dalam semester depan ada hasil publikasinya. Ini Disco untuk yang komersial. Karena komersial dia banyak fitur yang lebih stabil dibandingkan dengan yang ada di Pro-M dan juga dia lebih visualisasinya lebih bagus biasanya, lebih menarik karena dia digunakan untuk dunia industri. Itu mungkin Bu Eva mudah-mudahan bisa menjawab pertanyaannya.
Ya, terima kasih Pak Arif. Ini memang topik yang baru tapi juga sangat menarik Pak Arif. Kapan hari itu mungkin beberapa setahun yang lalu mungkin itu saya pernah ikut seminarnya dari KPK, Komisi Pemberantasan Korupsi. Nah, di KPK ini juga menggunakan proses mining gitu ya, mungkin dari awalnya dari proses discovery untuk melihat apakah ada fraud dari aplikasi-aplikasi yang digunakan di pemerintahan, kemudian untuk jadi melihat apakah yang dikerjakan atau yang diolah melalui aplikasi itu memang sesuai dengan SOP yang seharusnya. Nah, jadi seperti dibandingkan, jadi ada metode untuk similarity. Jadi KPK ini mengundang ahli atau akademisi dari universitas yang paham tentang proses mining, proses discovery, kemudian terkait pengelolaan event log dan seterusnya untuk dianalisis begitu untuk membangun sistem pelacakan fraud ini tadi sebenarnya Pak. Ini juga proyeknya KPK ke sana sebenarnya. Jadi melihat fraud itu. Jadi menarik.
Yeah.
Di beberapa penelitian kolega juga membuat semacam sistem untuk melihat seberapa besar kesesuaian atau similarity antara prosedur yang dijalankan melalui sistem terkomputerisasi dengan prosedur yang tertulis yang seharusnya yang ada di dokumentasinya. Itu juga ada yang penelitiannya ke arah sana. Dan memang hasilnya beberapa ya cukup menarik Pak Arif karena banyak beberapa proses yang prosedurnya itu similarity-nya tidak terlalu tinggi antara proses terkomputerisasinya dengan prosedur yang tertulis yang seharusnya dilakukan.
Iya, betul. Itu bagian dari yang selanjutnya, Bu. Setelah kita proses discovery itu ada yang namanya mana tadi ya? Conformance checking. Di conformance checking dia akan ngecek antara event log yang terdaftar di semua sistem dari mulai absensi gitu, kemudian dengan yang di SOP-nya, di proses modelnya. Nah itu kalau ada tidak kesesuaian itu bisa kelihatan berapa persen nggak sesuainya, apakah fatal apa enggak, dan di situ jadi masuk ke bidang lain, fraud detection tadi. Kalau saya baru pakainya buat ini, buat local konsistensi untuk dapatkan kombinasi dari proses-proses yang ada di web service. Belum sampai ke fraud detection-nya.
Ya, terima kasih Pak Arif. Pengetahuan baru untuk teman-teman mahasiswa di sini juga. Siapa tahu nanti ada yang tertarik skripsinya ke sana. Mumpung masih semester 3. Jadi belajarnya lebih banyak masih menuju ke skripsi. Dapat idenya dari sekarang Pak Arif. Okay. Jadi bisa dipelajari lebih lanjut, nanti bisa diskusi gitu ya. Mungkin yang tertarik dengan proses discovery ini, nah bisa jadi bahan skripsi.
Yeah.
Matur nuwun Pak Arif. Silakan Mas Christian dilanjutkan.
All right, thank you for the answer, Dr. Arif. And due to time constraint, I think I can finish the question and answer session and discussion. Thank you to Wifa who have asked question about business process discovery. Now, thank you so much again for Dr. Arif who has delivered an interesting material today and allow us to have a discussion about business process discovery. And thank you so much for everyone who have attended this lecture today. And for our gratitude to Dr. Arif for being willing to be our speaker today. The following is a symbolic handover of the certificate. The operator, please help to share the certificate to Dr. Arif. Okay. And for the operator, maybe please help us to take a picture together with Dr. Arif.
Yeah. Thank you very much.
Let me do the photo session. Please turn on the camera. In 1, 2, 3. Once again, 1, 2, 3. Thank you.
All right, thank you for the operator. And now we are at the end of the class. And remember, after the class, there will be a presence and a feedback form that will be provided by the committee. All the participants must fill the form to get the e-certificate. But before that, we will do a documentation without the certificate together first. For all the participants, please turn on the camera. And for the committee, please take the picture together.
Okay, let's do the photo session again. So please turn on your camera. Once again, please turn on the camera. Okay, let's do the photo session in 1, 2, 3. Again, 1, 2, 3. Last 1, 2, 3. Thank you.
Okay, thank you for the operator. And don't forget to fill the presence form and feedback form. Please the committee to share the presence form. And that's all for the guest lecture 2022. Thank you for joining the class, and special thanks to Dr. Arif for the lesson that I've given to the class today. Thank you and see you in the next guest lecture 2022.
Thank you all. See you.
Ya, terima kasih.
Sama-sama.
Recording stopped.
Jangan pergi dari diriku. Tak sanggup, 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 tak bersama seperti yang terjadi kemarin. Kini harus aku lewati langkah demi langkah yang menyepi. Jangan pergi dari diriku. Tak sanggup harus hidup tanpamu. Karena jauh lebih indah bila kita bersama seperti yang terjadi kemarin.